Hello, and welcome to the TechHub.training ALTERYX Delivery Chicken Challenge. In this video, I'll go through my solution for the challenge. Now, for this challenge, the solution is a very big workflow, so I've divided it into 3 sections. These follow the corresponding 3 instructions sections that are found within the challenge. But first off, I'll start here, where I input both the delivery data and the stores data. So looking at the data that comes in, you see that there's coordinates, store, and the dates. So we don't need the dates, we don't need a lot of the things within the coordinates. So the first thing we're going to do is we're going to use text to columns to clean and separate the coordinate values into the latitude and the longitude values. So to start, we use the text to columns tool, and we want to start by inputting the various delimiters that we need. So as you can see from the coordinates, they're surrounded in these parentheses, there's a space in between the 2 coordinates, and then there's also a comma. So in the delimiters, we put a comma, we put a space, and we put the 2 opening and closing parentheses. Now we know that these inputs are going to make 5 different columns as it splits on each delimiter. But we don't want every single column, so we're going to click this button here, which is skip empty columns, and that will give us an output that'll look like this. So from here we can move over to a select tool where we remove those 3 extra columns, and we can rename some of the columns into latitude and longitude. So that's looking a lot nicer already. So now that we have the latitude and longitude columns, we can then create the spatial points. So applying the longitude field and the latitude field, we have these centroids that are made, and using a browse tool, we can see that these are all the deliveries that are made. Make sure that you always add a base map, so then you can actually see the points on a map. And these are all the various deliveries that we have in our data set. I've also done the same for the stores. So I have these store locations, and I have these points created. And then from there, we want to make trade areas. So we want these 10-mile radius boundaries around the centroids. So to do that, I first need to filter out the Danville store, because Danville, as we know from the challenge, has a 20-mile radius and not a 10-mile radius. So filtering that out, I can have every other store on true, and then the Danville store on false. And so using a trade area tool, I can then specify the radius value. So for Danville, it's 20 miles, and for the other areas, it is 10 miles. And then I then reconnect the Danville back to the data with a union tool. And then from here, if I attach a browse tool to that, it's created these trade areas, as you can see on the left. So you can see here are the various boundary lines for the different stores. And then I want to combine the trade areas with the deliveries. And so to do that, I use a join tool. I just join based on store, and then I just deselect a couple of things that I don't need. And for the inner join, if I put a browse tool on that, it creates this whole map here. So you can see the trade areas and the various deliveries. So that's the first section that we need done. So now we can get on with the actual reporting. And so if I start with number 1 here. So for the first report, we know that we want to make a general report. We want to have a map of each individual store's deliveries, but we also want to include the trade areas of every other store on those individual maps. So connecting to that join tool that we made previously, we want to go through and filter each store out. As far as I'm aware, there isn't a tool available at the moment in ALTERYX that will give you a multiple output for separate filters. But if you do know a way, then feel free to add it to the comments on the challenge. I'm very interested to find a more efficient way to do this. But moving on to the first one, we have obviously the store is equal to Georgetown, and so every store that is equal to Georgetown will appear in true. So from there, we can combine that with the union tool. And so if I click on the union tool, you'll be able to see this green line that's connected to this previous union tool that has the stores. So that's because we want to grab the trade areas. So I union the trade areas onto this data set that has all the Georgetown stores, because I want to include the trade areas on the map. Connecting a browse tool to the union, we're able to see that for Georgetown, it looks like this. So we can see there's a lot of deliveries going on here in Paris, a couple of going into the Lexington area, but if we click on the trade area for Georgetown, we can see that this still mostly falls within the Georgetown area. Moving on from here, we then want to report the map. From there, we want to go to the report map tool, and this will report the actual map onto the PDF that we need. You can play around with some of the layers to change the colors and separate the things. You can also see that there's another wireless connection here to the union tool in order to grab those trade areas. For that reason, we don't actually need this original union tool here. This is just for the purpose of connecting to a browse tool. But going on from the report map tool, we've done this for every single store. So each store has gone through the same process of combining with the store locations and creating the individual store maps. Then we go to a union so we can get all the maps onto one tool. We can then go to layout and then we can render. The render tool, for this purpose I just chose a temporary PDF, but it will output a PDF that you can see. You can take this time to look at each individual store's deliveries and try to note any other specific things, specific problems that we might encounter. So Lexington looks pretty good. It doesn't look like it's going too far out into other people's boundaries. Frankfurt, we see that there are a lot of deliveries here on this mutual area. This mutual area with Georgetown and Frankfurt. So going back to Georgetown to verify, we can see that Georgetown is not really getting any deliveries in this mutual area. We know that one of Tom's rules is that for mutual areas, they should be kind of evenly split between the two stores. So that's going to be a problem area of concern that we want to look into. For Winchester, we can see that there are quite a few deliveries. There's quite a lot going outside of their actual trade area, kind of on the border there. Some going into Richmond. For Richmond, we see that there are no deliveries happening in Danville. Let's verify with Danville to make sure that there are no actual deliveries there. Oh, okay. We see that for Danville, there are a lot of deliveries happening in the Richmond area. So we know that Tom has a rule that the Danville employees are not actually supposed to be delivering in the Richmond area. So that's another problem area that we can look at. So moving on to section 2. In section 2, we want to be creating a gas compensation table just so that Tom can know how much money he's spending on gas for his employees. We also want to highlight these ambiguous areas and also these problem areas that we've seen in the previous maps. So the first step is to calculate the distances of the orders. So for that, we can use a distance tool, and we can just put the point or source of the centroid as the store centroid, and then the point that we want to go to is the centroid, which is relating to the deliveries. And so that gives us an output, which gives us a distance in miles of every single delivery from its relative store. And then we can calculate the gas compensation. So we know that Tom, he uses that IRS standard of 58.5 cents per mile. So taking the distance in miles and timesing it by that rate that we have, the 58 cents. And then here you'll see that we want to times it by 2. So the reason we want to times it by 2 is that we know that Tom, he's compensating not only the cost of driving to the customer to deliver the order, but also the cost of driving back to the individual store. So we want to times that by 2 because the driver is going 2 ways. And then we have a round function just at the end there, just so it rounds to 2 decimal places. Moving on, we can then go to a summary tool where we want to summarize by store, and then we want to have a sum of the gas compensation, and then we also want a count of the compensation because we want to know how many deliveries are occurring in each store, and that gives us this output as you can see below. Here we also take the opportunity to filter the ambiguous deliveries. So we know that ambiguous deliveries are those deliveries that occur outside of the trade areas. So in order to filter for those ambiguous deliveries, we want to find any deliveries that occur either outside of the 10-mile range of the store, or it occurs 20 miles outside of Danville specifically. And so for those which are true, we can then summarize those values into these gas compensations and number of deliveries. And then we can use a join tool to join those ambiguous totals to the previous summary of the overall totals that we have. And so here you can see that using the join tool, we can see that here are both the total and the ambiguous. Connecting a browse tool to this filter before, we are able to actually take a look at what these ambiguous deliveries look like. So we can see that all these deliveries are occurring outside of the respected store. They may look like they're within the trade area of the specific store, but we know that these individual deliveries are coming from a store that is outside of its delivery area. So moving on to this join tool here, we see that it is adding some problem deliveries here. So these problem delivery variables, they're coming from section 3. So at this point, I'm going to stop and I'm going to go to section 3, and then I'll come back and finish off the workflow in section 2 again. Okay, now that we have number 3 open, we can see that coming from this trade area union that we had previously, just here from the start, it's leading into these filter tools. And these filter tools, they're going to filter for Richmond and for Georgetown, because we saw that those were two areas that we were a little concerned about from the browse tools before in section 1. You'll also see in these filter tools that we're filtering for Danville and for Frankfort. It's a little covered, but we're filtering for Frankfort as a store. You'll see that there's a wireless connection here of these two filters leading back to section 2. So it's actually connecting to the false on this filtered ambiguous deliveries. So these are all the deliveries that are occurring within each respective trade area of each store. And the reason that we're filtering off of this section is because we want to know what deliveries are occurring in that mutual area between the two stores. So for Danville, we know that it borders with Richmond, and for Georgetown, it's bordering with Frankfort. So we want to know that mutual area. So moving on, we go to a find nearest tool. So this find nearest tool at the top is going to be finding the Danville deliveries in the Richmond area. So I've attached a browse tool to it so that you can see the output that I'm creating here. You can see that for the Danville, I have this Danville trade area, and then for Richmond, it's showing me all the deliveries that are happening within the Richmond trade area that are actually from Danville. So we know that these are these problem deliveries that we're talking about because they're all coming from one store when they should be evenly split between the two. I also have the Frankfurt deliveries that are happening in Georgetown area as well, which is the same principle. Moving on, we then summarize each individual set, accounting for the total gas compensation of those problem deliveries and then how many problem deliveries there are. And then we union them together, and then we pull it back into section 2. But in order to complete this last bit, we then create maps, as you can see. So we pull those 3 maps that we've generated that I showed before using a report map tool. And these are then also fed back into the section 2, which I'll complete now. So where we last left off in section 2 was this join tool. So we know that these problem deliveries and problem gas compensation is coming from section 3. So we're joining that together. But we know that not every store has problem deliveries. So you'll see that there's a left join that occurs and there's also an inner join. So we want to union them together like so that we can have the complete data table. From there, we then create the table for reporting, and you can order them however you like. I just kept it as the default. We then union everything together, and as you can see, there's these green wireless connections that are going back to section 3. They're actually going back to the report map tools of each individual map that I was showing you before. From here, we can then use a layout to combine the tables and the maps, and then we get that output through the render tool like we did in section 1. After running the workflows, I wanted to show you the two outputs that are created with the PDFs. So here we have the first report, which is just the general overview, and we can see that here is the Georgetown store, here's the Lexington, here is the Frankfurt, and then here is the Winchester, Richmond, and then finally Danville. For the second report that we made, we have this data table here. You can add some sort of stylistic things that you want. I just did the basic sort of default level. And you can see that here are all the numbers that we need. We have the total gas compensation and number of deliveries, and then we also have the ambiguous deliveries and those problem deliveries that are happening in Frankfurt and Danville. And then we also included the maps here, so you can see with the legend, you can hear it's the Richmond and the Danville areas. You can see all these Danville deliveries occurring within the Richmond trade area. And then below you can see the same for Georgetown and Frankfurt, all these Frankfurt deliveries going into Georgetown. And then finally, we have the stores and the deliveries, these ambiguous deliveries occurring outside of each store. Thank you for watching the solution video for this challenge. I'm excited to see the different outputs that everybody made and the different reports that were generated. Let me know if you had a different way of tackling this challenge. I'm always interested in learning new efficient ways to use ALTERYX and to generate reports such as these. Thank you.